Have you ever wondered about the genesis of the elements that pervade our existence, from the air that fills our lungs to the terra firma beneath us? This fundamental question is the impetus for our journey today. Our existence is a complex tapestry of elements, each with its cryptic tale of genesis. Isn't it astonishing to realize that the iron coursing through your veins, the calcium fortifying your bones, and even the oxygen you're drawing in at this very moment all have celestial roots? Yes, indeed. The elements that constitute and everything around us have been birthed in the enigmatic heart of stars. These elements have been dispersed across the cosmos by cataclysmic events and eventually coalesced to form our world. Are you to delve into the enigmas of the cosmos? Let's embark on a journey through the annals of time, from the inception of the universe to the present day, to uncover the cryptic origins of elements. Our story begins with the Big Bang, the birth of the universe around 13.8 billion years ago. Imagine this, a singularity, a point of infinite density and unimaginable heat suddenly expanding. This is the Big Bang. It's not an explosion in the traditional sense, but rather an expansion of space itself, stretching and cooling over time. In the blink of an eye, or rather in a fraction of a second, the universe expanded from a size smaller than an atom to something astronomically larger. This was a time of extreme conditions, with temperatures reaching a staggering 1 billion degrees Celsius. In these blistering conditions, the very building blocks of matter came into existence. Quarks and leptons, the smallest particles we know of, began to form, colliding and combining in the energy-dense environment of the early universe. As the universe continued to expand and cool, these particles began to come together, forming protons and neutrons. About 3 minutes into the universe's existence, something remarkable happened. The universe had cooled down enough for these protons and neutrons to start combining to form atomic nuclei in a process known as nucleosynthesis. The first elements were born. The vast majority of these first nuclei was simple, consisting of either a single proton, forming hydrogen, or 2 protons and 2 neutrons, forming helium. These elements were incredibly stable, able to withstand the still extreme temperatures and pressures of the early universe. For hundreds of thousands of years, the universe continued to expand and cool, eventually allowing these hydrogen and helium nuclei to capture electrons, forming fully fledged atoms. These atoms would go on to form the first stars and galaxies, setting the stage for the rest of cosmic history. These first 2 elements, hydrogen and helium, formed the basis for everything else that was to come. As the universe cooled and expanded, stars began to form, and within these cosmic furnaces, the process of stellar nucleosynthesis began. This process, as the name suggests, is the synthesis or creation of new atomic nuclei from pre-existing protons and neutrons, the building blocks of atoms. The heart of a star is a pressure cooker, a place of unimaginable heat and pressure. The core of a star, especially a young one, is primarily made up of hydrogen, the lightest and most abundant element in the universe. Under the immense pressure and temperature, hydrogen atoms come together in a process known as nuclear fusion, producing helium and releasing a tremendous amount of energy. This energy is what makes stars shine so brightly and gives them their heat. But the process doesn't stop there. As stars age and their hydrogen supply begins to dwindle, they start to fuse helium atoms together, creating heavier elements like carbon and oxygen. This process continues, with the star creating heavier and heavier elements all the way up to iron. Iron, however, is a bit of a dead end. It's extremely stable and requires more energy to fuse than it produces, effectively quenching the nuclear reactions. This is a critical point in a star's life. When a star has converted its core to iron, it's essentially living on borrowed time. The nuclear fusion process that powers a star also maintains its equilibrium, balancing the inward pull of gravity. Once the fusion stops, gravity takes over, causing the star to collapse under its own weight. This collapse can trigger a supernova, a cataclysmic explosion that sends the star's outer layers, including the heavier elements it has created, hurtling into space. The death of these stars would then scatter these elements across the universe, setting the stage for the formation of planets and life. So, in a very real sense, we are all made of star stuff, a cosmic legacy of stellar nucleosynthesis. But what about the heavier elements like gold and uranium? These elements require much more energy to form than can be found in ordinary stars. So where do they come from? The answer lies in the extraordinary events of supernovae and neutron-star collisions. You see, there are times when the universe decides to go big, and when it does, it results in some of the most powerful and energetic events known to science. Let's start with supernovae. These are the final explosive moments of massive stars. Stars that are much larger than our Sun burn through their nuclear fuel at a much faster rate. When their fuel runs out, these stars collapse under their own gravity and then explode spectacularly, releasing an immense amount of energy. Now, this is not your ordinary explosion. We're talking about a blast so powerful that for a brief moment a single supernova can outshine an entire galaxy. In this crucible of unimaginable heat and pressure, atoms are smashed together with such force that new, heavier elements are created. Gold, uranium, and other heavy elements owe their existence to these cosmic fireworks. But supernovae aren't the only game in town. Neutron star collisions also play a part. Neutron stars are the ultra-dense remnants of supernovae. When two of these cosmic heavyweights collide, they create conditions so extreme that even heavier elements can be formed. It's like the universe's own high-energy particle accelerator. These cataclysmic events not only create the heavier elements, they also scatter them across the universe. In the aftermath of a supernova or neutron star collision, the newly formed elements are ejected into space. Carried by stellar winds and shockwaves, these elements travel across the cosmos, eventually finding their way into interstellar clouds. These clouds can then collapse to form new stars and planets, enriched with the heavier elements. These violent events not only create heavier elements, but also scatter them across the universe, enriching future generations of stars and planets. So, how did these elements end up on Earth? An intriguing question indeed. You see, it's all part of a cosmic dance that began billions of years ago. The elements that make up our world, the air we breathe, the ground beneath our feet, they all originated in the hearts of stars and the explosive spectacles of supernovae. But how did they make their way here? The answer lies in the formation of our solar system and our very own Earth. Around 4.5 billion years ago, a giant molecular cloud in our Milky Way galaxy began to collapse under its own gravity. This cloud was not just made of hydrogen and helium, but also contained the heavier elements produced by stars and dispersed by supernovae. As the cloud collapsed, it began to spin, forming a flattened disk with a central bulge. It was in this bulge that our Sun was born. But what about the rest of the disk? The remaining material, a mixture of gas and dust enriched with the elements from ancient stars, didn't go to waste. Instead, it began to clump together, forming planetesimals and protoplanets. Over time, these planetesimals and protoplanets continued to collide and coalesce, eventually forming the planets of our solar system, including our Earth. So when you look at the world around you, remember that every element you see, every grain of sand, every drop of water, every breath of air, is a piece of cosmic history. These elements have journeyed through space, survived cataclysmic events, and participated in the formation of our world. In essence, the Earth is a cosmic recycling center. It's taken the remnants of ancient stars, the debris from cosmic explosions, and transformed them into a planet teeming with life. So, the elements we see around us today are the remnants of ancient stars and cataclysmic cosmic events. So, we've journeyed from the birth of the universe to the present day, tracing the origin of the elements. We've learned that the universe was born in a fiery Big Bang, with only the lightest elements, hydrogen and helium, forming in its infancy. We've discovered that it was in the heart of stars, through a process called stellar nucleosynthesis, that heavier elements like carbon and oxygen were forged. We've seen how supernovae, the explosive deaths of massive stars, created the heaviest elements and scattered them across the cosmos. And we've explored how those elements found their way to Earth, becoming the building blocks of our planet and everything on it, including us. The journey of the elements, from the heart of stars to the palm of your hand, is a testament to the interconnectedness of all things in the universe. The next time you take a breath of air or pick up a piece of metal, remember, you're interacting with the remnants of stars and the echoes of the Big Bang. Isn't that something to marvel at?